Hey everyone, Dr. Kayla Ryan here. I want to start by taking a calm, clear look at what has just unfolded on the sun, because these past few days have been unlike anything we've seen in recent months. We have just recorded another X-class flare, this one in X4.0, which makes it the fourth major X-class eruption in only a matter of days. That alone is noteworthy, but when you put it beside the pattern of activity that has been unfolding, it becomes even more remarkable. Before this X4.0 event, we had an X1.7, an X1.2, and then that powerful X5.1 flare. All three of those early explosions launched coronal mass ejections directly toward Earth, and each one hit us head-on. The combined impact produced a G4 to G5 minus geomagnetic storm, one of the strongest of the current solar cycle. The auroras generated by that storm were seen as far south as Mexico and Spain, reaching latitudes that rarely experience any visible activity at all. For many observers, it was a once-in-a-lifetime display. This latest flare, the X4.0, is different in its geometry. Even though it is extremely powerful, it only has a small Earth-directed component. Most of the plasma and magnetic structure ejected from this eruption is moving ahead of Earth's orbit rather than straight toward us. We will likely feel a shock front, a brief pulse sweeping past our magnetic field, but the dense core of the eruption will miss our planet. That makes its energetic signature important, but the direct impact less significant than the earlier flares. Still, what matters most right now is not just the individual strength of these events. It's the timing. For major X-class flares in a tight cluster, occurring after a period of relative quiet, and emerging from the same sunspot group, this raises deeper questions about the rhythm and structure of what the sun is doing. The eruptions are impressive, but the pattern they form is even more so. And that pattern is just the beginning of a much bigger story that has been building over the past month. Over the past month, something unusual has been unfolding above us. Something that becomes clear only when you line up the timing of each major solar event with the positions of a few very specific objects in our solar system. The recent surge in X-class flares has matched almost perfectly with the positions of three comets, 3I Atlas, Comet A6 Lemon, and Comet T1 Atlas. Each of these objects has been moving through its own orbital path, yet the most powerful solar activity has erupted exactly during the windows when the same sunspot group has aligned or nearly aligned with them. To understand the timing more clearly, look at their perihelion dates. 3I Atlas reached its closest point to the Sun on October 29th. A 6 Lemon followed soon after, with its perihelion on November the 7th and 8th. And T1 Atlas is heading toward its own perihelion in early December. These dates might seem like isolated astronomical events, but when placed against the timeline of the Sun's recent behavior, the overlap is impossible to ignore. Each major flare sequence has occurred within days of these comets reaching the area of their greatest solar influence. The first sign of a hidden pattern appeared when the sunspot group responsible for all four X-class flares initially emerged. It was born on the Earth-facing side of the Sun more than a month ago, at a time when A6 Lemon and T1 Atlas were both closer to the Sun. But at that early stage, the group was small and weak. It did not yet have the magnetic complexity to generate significant activity. Only when it rotated toward the region of the Sun that lined up with 3I Atlas did it come alive. Around October 21st, as that alignment tightened, the sunspot group suddenly intensified and began producing stronger flares. From that moment on, the correlation grew stronger. As the Sun's rotation carried the sunspot back into alignment with A6 Lemon and later T1 Atlas, more powerful flares followed. And now, as it rotates once again toward the sector aligned with 3I Atlas, the pattern is repeating itself. This creates a central question that frames the entire narrative. Why does the Sun consistently flare its hardest when the sunspot group approaches alignment with these particular objects? Whether coincidence, resonance, or something more subtle, the timing stands out, and it is shaping the entire month sequence of solar behavior. When this sunspot group first emerged on the visible face of the Sun, it appeared unremarkable, just a small cluster of magnetic disturbances, weak and mostly quiet. For several days it showed little sign that it would become one of the most active regions of the entire solar cycle. But that changed as it approached the sector the Sun aligned with 3I Atlas. Around October 21st, something shifted. The sunspot's magnetic field began to intensify, its structure became more complex, and the region started producing stronger bursts of activity. This marked the moment when the group effectively woke up, and from that point onward, it remained active throughout the entire solar rotation. As the sun carried this region across its disk, a sequence began to unfold that aligned almost perfectly with the positions of the comets nearby. When the sunspot group moved into alignment with A6 Lemon, it produced a cluster of new flares. Then, as it rotated to the part of the sun correlated with T1 Atlas, the activity continued, building momentum and energy. Each time it crossed into the same longitudinal window as one of these comets, its behavior intensified. And now, as it turns back toward the area aligned with 3I Atlas again, the flaring has returned, including the latest X4.0 event. The geometry of these alignments is subtle but important. The region is currently about 15 to 20 degrees offset from the exact 90-degree limb alignment, where limb flares often connect strongly with Earth. Even from this slight angle, the pattern of activation has remained consistent. That offset helps explain why some eruptions have been more Earth-directed while others have launched off to the side, but it doesn't change the underlying timing. Across this entire month, the sunspot group has behaved almost like a living character, sleeping when it drifts away from these alignment zones, waking as it approaches them, pulsing with energy when the geometry tightens, and quieting again as it moves on. It has responded not randomly, but rhythmically, as though the sun itself were following a larger pattern shaped by the positions of objects around it. And the most striking part is that the activation window around 3I Atlas seems unusually wide, spanning far more days than would normally be expected for a single region influencing solar behavior. As we move toward the middle of the month, the next few days hold particular importance. The sunspot responsible for the recent sequence of X-class flares is rotating into a position where it may either maintain its heightened activity or begin to quiet down. November the 17th and 18th will be telling. If the region continues to flare during that window, it would further reinforce the pattern we have been watching for weeks, activity rising as it approaches the same longitudinal zone associated with 3I Atlas. If it quiets, that would mark a temporary pause before the next alignment tightens. Either outcome will offer valuable clues about the rhythm this region has been following. But the story doesn't end there. On November the 19th and 20th, the solar system itself moves into a configuration that is unusually precise. The Sun, Mercury, the Moon, Earth, and Uranus will line up within less than 2 degrees, forming a near-perfect alignment stretching across hundreds of millions of kilometers. Mercury will be at inferior conjunction, passing directly between Earth and the Sun. At the same time, the Moon will reach its micro-new moon phase at the most distant point in its orbit while still forming that direct alignment with the Sun. And on the far side of this line, Uranus will be at opposition, its version of a full moon, where it sits directly opposite the Sun from Earth perspective. That by itself is a remarkable symmetry, but it becomes even more interesting when you look at the broader harmonic geometry shaping the outer solar system. Saturn and Neptune are nearing their rare synodic conjunction, a cycle that resets only every few decades. Pluto sits at an angle that interacts with this pattern, adding another layer of gravitational and electromagnetic influence. Jupiter and Venus also form meaningful angles relative to this alignment, contributing their own subtle but measurable effects. Each of these elements alone would be notable, but together they create a rare energetic landscape, one shaped by alignment, resonance, and timing. As these dates approach, they mark a period where the Sun, the planets, and the background geometry of the solar system all shift into a configuration that has historically coincided with increased solar and geophysical activity. There is another detail in the recent activity that stands out just as strongly as the flares themselves, and it has nothing to do with magnitude or direction. It has to do with timing, very specific timing. All 4 of the major X-class flares erupted within the same narrow universal time window, clustered between 7:30 and 10:04 universal time. That kind of repetition is unusual, especially across several days of independent solar events. On November 9th, the flare peaked at 7:30 universal time. The next day, November 10th, the X1.2 event struck at 9:10 universal time. Then came the X5.1 on November 11th at 10:04 universal time. And finally, the latest X4.0 erupted on November 14th at 8:30 universal time. 4 separate days, 4 separate explosions, all landing inside a span of just a few hours on the universal clock. When the Sun produces events this powerful, timing often varies widely. These flares, however, followed a rhythm. This kind of synchronicity raises interesting questions about the geometry of Earth's rotation relative to the Sun at those moments. Universal time reflects when certain regions of Earth are facing the Sun most directly. If flare after flare emerges while the same part of Earth rotates into exposure, it suggests that something about the magnetic connectivity between Earth and the Sun during those hours is especially strong. Field lines linking our planet to the active region may have been perfectly aligned during that slice of the day, creating a conductive magnetic bridge that made these hours the most favorable for flare energy to reach its peak. Patterns like this don't appear often. When four major eruptions occur in the same universal time window, across different days and increasing in strength, it's hard to consider it coincidence. 4 times in a row. This isn't random. When we look at the energetic data from this latest X4.0 flare, the numbers tell a clear story about its intensity. Almost immediately after the eruption, there was a sharp spike in high-energy protons, particles accelerated to near light speed by the shock front of the flare. Alongside them came fast-moving alpha particles and a surge of electrons, all riding the magnetic wave released from the sun's surface. These bursts in proton flux are some of the clearest indicators that an explosion was powerful, because only the strongest event can accelerate particles to those extreme energies. Earlier this month, one of the previous flares even produced a significant increase in the greater than 500 MeV flux, something only the most energetic solar events are capable of generating. When comparing the X4.0 flare to the earlier 3, it stands firmly among the strongest we have seen this entire solar cycle. The X5.1 was technically more intense in peak magnitude, but the particle response from this X4.0 shows that its underlying energy was substantial. Even though much of its mass was directed away from Earth, the immediate rise in high-energy particles reveals how forceful the explosion was at its core. It joins a sequence of flares that, taken together, represent one of the most active stretches of the current cycle. What makes this even more intriguing is the rhythm of activity surrounding it. After the alignment with T1 Atlas loosened, the sunspot entered a brief calm phase. Activity dipped, flare frequency dropped, and the region seemed to quiet. But as it rotated back toward the longitudinal zone correlated with 3I Atlas, the energy rose again and the X4.0 event emerged. This repeating rise and fall pattern tied to the positions of these objects invites deeper questions about the underlying mechanism. There is speculation, cautious, but worth noting, that 3I Atlas may be an interstellar traveler. If traced far enough back, its origin could even lie outside our galaxy. Objects like that could carry different resonance frequencies, different structural responses to solar radiation, or simply different interactions with the sun's magnetic field. None of this is confirmed, and we don't know the cause behind these alignments and the flares that follow them. But the pattern is interesting, and it continues to repeat in ways that are difficult to ignore. When we break down the coronagraph imagery from this latest eruption, the geometry becomes clear almost immediately. From Earth's perspective, the plasma from the X4.0 flare is moving strongly toward the west, angled away from the direct Earth-Sun line, and sweeping outward into the region just beyond our orbit. When we switch to the Stereo A spacecraft, positioned about 30 degrees ahead of Earth, the same westward blast is visible from a completely different vantage point. Both perspectives agree. The eruption is not aimed squarely at Earth, but is instead pushing outward toward the sector of the inner solar system where 3I Atlas is currently located. That directional correspondence matters. The region of space receiving the densest part of the plasma cloud is the same region occupied by 3I Atlas, reinforcing the idea that the comet is repeatedly positioned inside the trajectory of the most powerful ejections. Even though these flares originate from an Earth-facing sunspot, their strongest outbursts have consistently moved toward the same heliographic zone where 3I Atlas resides. The coincidence is hard to miss. When we look at the NOAA space weather model, the projection aligns with what the coronagraphs show. The shock front from the X4.0 flare is expected to arrive at Earth fast, sharp, and brief, but the majority of the mass, the dense core of the ejection, slides past ahead of our orbital path. Because only the shock grazes us, the resulting geomagnetic activity is expected to fall within the G1 to G2 range, enough to create noticeable disturbances in some auroral activity, but nothing like the G4, G5 storm triggered by the earlier Earth-directed CMEs. This also highlights something important about our magnetic connectivity to the active region. As the sunspot rotates toward the solar limb, its field lines begin to connect more efficiently with Earth, even when the flare itself is not aimed at us. Limb flares can sometimes have stronger magnetic coupling because the Parker spiral of the interplanetary magnetic field favors that angle. So while the bulk of the plasma is moving westward, the shock and some high-energy particles still find their way into Earth's magnetosphere along these curved field lines. But the spacecraft position ahead of Earth in its orbit, like Stereo A, will take the strongest hit. Those probes sit directly inside the primary path of the ejected material and will measure the highest particle densities and the most intense velocity spikes. Their data will give us the clearest view of how forceful this eruption truly was, and how directly it swept across the region of space that 3I Atlas is currently moving through. If we step back and replay the past month as if watching a documentary, a clear narrative begins to form, one that links the birth of a sunspot, the motion of 3 comets, and a sequence of solar eruptions that seem to rise and fall with remarkable timing. It begins with a quiet emergence of the sunspot group on the Earth-facing side of the Sun. At first, it was small and simple, producing only minor M-class warm-up flares, the kind of activity expected from a region still developing its magnetic structure. Nothing about its early behavior hinted at the chain of powerful events that would follow. Then came October 21st. As the sunspot rotated toward the heliographic longitude aligned with 3I Atlas, it suddenly erupted with a major explosion, one of the defining moments of the month. This was the first flare that clearly showed the region was capable of much more than M-class bursts. From that point onward, the activity continued steadily through October 29th, when 3I Atlas reached its perihelion. During this entire stretch, the sunspot produced consistent flaring, as if drawing energy from the tightening geometry with the comet. After perihelion, the sun entered a brief quiet period. Activity dropped noticeably in early November, coinciding with the sunspot drifting away from the alignment zone associated with 3I Atlas. But the calm did not last. On November 3rd, as the region lined up with Comet A6 Lemon, and with Mercury forming conjunction on the same line, the sunspot sparked another significant flare. The timing matched the geometry almost perfectly, marking the beginning of the month's second activation window. This set the stage for the intense sequence of November 9 through 11, when 3 consecutive X-class flares erupted while the sunspot was aligned with both T1 Atlas and Earth. Those 3 days produced the X1.7, the X1.2, and the massive X5.1 eruption. The alignments during that period were unusually tight, and the resulting activity was among the strongest we have seen in the current solar cycle. The flares were Earth-directed, and the CMEs they produced generated the G4 to G5 geomagnetic storm that sent auroras deep into low latitudes. Then, on November 14th, the pattern repeated yet again. As the sunspot rotated back toward the sector associated with 3I Atlas, its activity surged and produced the X4.0 flare. Even though this eruption was angled westward, the timing once again matched the position of 3I Atlas within just a few degrees. It marked the beginning of what appears to be a third activation window connected to the same comet. The positions of the comets themselves add more dimension to this pattern. A 6 Lemon and T1 Atlas sit well above the ecliptic plane, elevated high in the northern solar hemisphere. 3I Atlas, on the other hand, lies almost exactly along the ecliptic, placing it inside the sheet of solar wind and magnetic structures that sweep outward from the sun. This makes it uniquely positioned to intersect the paths of CMEs and energetic particles. When viewed as a whole, the month reveals a tidal-like pattern of solar activity rising and falling in step with the alignments of these 3 comets. Every major flare event, every X-class eruption, every significant CME, has occurred close to a moment where the sunspot group's longitude matched one of the comets and a nearby planet. The pattern is not perfect, but it is consistent enough to stand out, creating a month-long rhythm that is hard to dismiss. If the current trajectory of 3I Atlas continues unchanged, and so far every measurement suggests that it will, then Earth will make its closest approach to this object on December 19th. Dr. Kale emphasizes that this date marks more than just a passing milestone. It represents a moment when the geometry between the Sun, Earth, and 3I Atlas becomes as tight as it will ever be during this passage. And if the past month has shown anything, it's that the timing of this object position often coincides with sudden bursts of solar activity. With more solar storms likely in the coming weeks, he raises a possibility that 3I Atlas itself could continue to evolve. Its tail already changed dramatically after perihelion, extending and reshaping as recent solar winds swept past it. Stronger eruptions could intensify that process. A major CME glancing across its trajectory might alter the structure of its tail again, or even cause small-scale fragmentation. These ideas aren't predictions. They're open scientific possibilities that naturally follow from how icy, dusty interstellar bodies react under extreme solar conditions. The bigger questions revolve around the object's physical nature. What is its true density? How much of it is volatile ice, and how much is rocky or metallic? Does it contain internal fractures or cavities that respond unusually to solar heating? And perhaps the most curious question of all, why has so much of the sun's strongest activity this month occurred when the sunspot group aligned with the position of this single object? Dr. Kale revisits a hypothesis discussed earlier, that 3I Atlas may not simply be another long-period comet, but an interstellar visitor carrying properties we don't yet fully understand. Its orbital behavior and resonance with solar activity have raised the possibility, however remote, that tracing its path back far enough could place its origin outside our solar neighborhood, perhaps even beyond our galactic environment. He remains cautious, stating firmly that correlation does not prove causation. But he also notes that the parallels are too consistent to ignore. With the closest approach approaching on December 19th, he frames the moment as both a scientific opportunity and a potential turning point in understanding why this object appears so deeply intertwined with the sun's behavior during this cycle. Using Solar System Scope as his guide, Dr. Kale walks the audience through the geometry of November 19th to 20th with the precision of a physicist and the clarity of a teacher. He begins with Mercury, which is currently retrograde from Earth's perspective and moving into its inferior conjunction. That moment, when Mercury slips directly between Earth and the Sun, creates a narrow corridor of gravitational and magnetic influence that has historically shown measurable signatures in solar wind behavior and electromagnetic coupling. As Mercury approaches this exact alignment, its orbital speed increases, tightening the geometry even further. At the same time, the Moon is nearing what astronomers call a micro-new moon. Because it is at the farthest point in its orbit, it appears smaller and exerts slightly weaker tidal force than the supermoon, but its alignment geometry becomes more precise. During this new moon phase, the Moon passes almost directly between Earth and the Sun, creating a three-body alignment that overlaps with Mercury's inferior conjunction. Dr. Kale highlights how unusual it is for the Moon to be near its apogee while Mercury simultaneously crosses the same alignment corridor. He then extends a line outward to show Uranus at opposition, its version of a full moon phase, but on a planetary scale. Uranus, Earth, and the Sun fall almost perfectly into a straight line, completing a five-body geometry that is less than 2 degrees from perfect alignment. With Uranus on the opposite side of the Sun-Moon-Mercury line, the system resembles a stretched gravitational cord, with Earth caught between inner and outer planetary forces. Beyond this immediate configuration lies a deeper layer of long-term celestial patterns. Saturn and Neptune are entering a rare synodic reset, a near-perfect conjunction that only occurs roughly every 37 years. This alignment influences long-range solar system harmonics, subtly shaping the background state of tidal forces within the heliosphere. Pluto contributes its own ultra-long alignment, operating on a timescale of centuries, while Jupiter and Venus occupy angular positions that support and amplify the overall harmonic pattern. Dr. Kale is careful in his tone. He stresses that none of this is astrology. These are gravitational harmonics, tidal forces, and magnetic interactions with documented historical correlations. Planetary alignments don't cause solar flares in a direct push-button way, but they influence the underlying energetic state of the solar system, creating windows where certain events become more likely. It is within these windows, he explains, that the Sun's recent behavior seems to fit, and the timing of the November 19th to 20th geometry marks one of the most significant energetic peaks of the season. On January 9th, the solar system will enter a geometric configuration that is far more precise and far more layered than the November alignment. Dr. Kale describes it as an ultra-critical moment because 6 major bodies, Jupiter, Earth, the Sun, Mercury, Venus, and Mars, will fall into a near-straight line. This isn't symbolic or astrological. It is a physical stacking of gravitational, magnetic, and tidal influences that rarely occurs with this level of symmetry. Jupiter, with the strongest magnetic field of any planet in the solar system, anchors one end of the alignment. Earth, possessing the strongest magnetosphere among the inner planets, sits between Jupiter and the Sun, effectively acting as a conductor within the chain. On the opposite side of the Sun, Mercury, Venus, and Mars form a compact lineup that tightens the overall geometry. Because Mercury moves so quickly, it only spends a brief time within perfect alignment, but during that window it adds an additional magnetic and gravitational signature. Venus contributes mass and stability, and Mars completes the sequence with its own orbital rhythm. Together, the configuration resembles a taut gravitational string running through the inner solar system, pulling multiple resonances into a narrow bandwidth. Dr. Kale emphasizes that this is not a predictive model for disaster or upheaval. Instead, it is a recognition of how rare these multiplanet alignments are and how often, historically, they have coincided with energetic variations. When large magnetic fields come into approximate alignment, the Sun sometimes enters a more reactive state. When planets stack, small but measurable tidal pulses can propagate through the heliosphere, occasionally translating into subtle crustal stress waves on Earth, effects that are real but extremely difficult to detect directly. And when magnetospheres line up, the Earth's own field can experience temporary distortions or shifts as it absorbs and redirects incoming solar wind. He makes it clear that none of this guarantees any specific outcome. It is entirely possible that the date passes quietly. But when examining long-term solar records and geophysical data, these types of alignments consistently appear near periods of heightened activity. The January 9 configuration stands out not because of fear or speculation, but because of how cleanly the magnetic and tidal forces stack together. It represents a moment where the system becomes unusually ordered, and whenever that happens, the Sun, and sometimes the Earth, tends to respond. Dr. Kale turns his attention to the earthquake swarm off the coast of Japan, noting that the sequence has shown no signs of fully settling. The most recent event, a magnitude 5.3, arrived less than a day ago, extending a pattern that now includes more than 24 magnitude 5 or higher quakes. Within that cluster lie several stronger shocks, a 6.8, a 6.4, and a 6.0, all occurring within the same tight window of activity. What makes this sequence notable is not only its intensity but its timing. Every major pulse in the swarm unfolded during the stretch of X-class solar flares between November 9th and November 11th, when the Sun launched some of the strongest electromagnetic disturbances of the cycle. As he lays out the data, he points to a familiar pattern. The foreshock behavior of this region bears similarities to what was documented before the March 2011 Tohoku earthquake. Back then, too, the swarm built gradually, with multiple magnitude 5 and magnitude 6 quakes leading up to the main rupture. And at that time as well, the Sun was unusually active, producing Earth-facing eruptions in the days before the magnitude 9.1 event. The parallel is not a prediction but a historical reference point, a reminder that this part of the subduction zone had produced some of the most significant seismic events in recorded history. Depth plays a critical role here. Many of the recent quakes have been shallow, clustering within the upper layers of the crust where stress transfer can rapidly destabilize the seafloor. Because this is a megathrust fault zone, where the Pacific plate dives beneath the North American plate, shallow ruptures have the potential to displace large volumes of water, creating tsunami-genic conditions even when the magnitude is not extreme. A magnitude 7+ event in this setting could generate powerful waves, especially given how close the swarm is to the region's most sensitive fault structures. Dr. Kale explains that the window of elevated risk extends through the end of November, not because an earthquake is expected or forecasted, but because several influencing factors converge during this period. Lunar phases, particularly new moons and full moons, historically increase global earthquake rates by roughly 0.5 to 1%. The upcoming new moon brings stronger gravitational tides, which subtly deform the crust and can increase fracturing along fault lines already under pressure. Combined with the aftermath of recent geomagnetic storms, which can alter the upper atmospheric and magnetospheric environment surrounding Earth, these conditions contribute to a period where tectonic systems may behave more sensitively. He emphasizes that none of this means disaster is imminent. Earthquakes remain inherently unpredictable, and most swarms resolve quietly. But given the seismic history of this region, the shallow depths, the ongoing swarm activity, and the coincidence with recent solar events, Dr. Kale concludes that this particular zone deserves elevated attention through the end of the month. It is a window to watch carefully, not out of fear, but out of respect for the geological forces at play. The recent G5-level geomagnetic storm was powerful enough to reshape Earth's radiation environment, and Dr. Kale explains that over the next several weeks we may temporarily see 3 or even 4 distinct radiation belts instead of the usual 2. When storms of this magnitude strike, they inject vast numbers of high-energy particles into the magnetosphere, creating layered structures that take weeks, sometimes nearly 2 months, to fully relax back to normal. These belts trap charged particles at different altitudes and intensities, forming a multiband configuration that subtly alters how energy moves around the planet. He describes how these changes extend far beyond space. The magnetosphere is the outer shield, reacting first to the solar wind and then passing that energetic influence down through the atmospheric system. Strong geomagnetic disturbances can modify ionospheric currents, alter global electric circuits, and shift the balance of particle flows entering the polar regions. Those atmospheric changes, in turn, affect the layers below them. Electrical variations propagate downward, influencing temperature gradients, pressure waves, and even the behavior of the jet streams. From there, the coupling extends into the lithosphere. While the crust does not react instantly or dramatically, prolonged changes in the electromagnetic environment can influence stress distribution in subtle ways. Earth's crust, mantle, and core exist within the same electromagnetic envelope that surrounds the planet, and when the envelope changes, the deeper layers respond over time through shifts in conductivity, heat flow, and mechanical tension. These effects are not well understood, and the scientific models are still evolving. But the correlations between strong space weather events and certain geophysical responses continue to appear in long-term datasets. Dr. Kale emphasizes that this field of study is still in its early stages. Space weather is not isolated from the planet. It is woven into the same system. Radiation belts, atmospheric circuitry, and lithospheric stress all share energetic pathways. And as he closes this segment, he notes that we are only beginning to understand how these layers interact, and how events on the Sun can echo through Earth's deeper structure in ways we are still learning to measure. As Dr. Kale moves into his closing reflections, he brings together the many threads that have shaped this month's unfolding story. 4 X-class flays in rapid succession, each arriving within a narrow timing window, set the backdrop for a period of exceptional solar activity. The alignments involving 3II Atlas, Comet A6 Lemon, and T1 Atlas created a repeating pattern that coincided with those flays, forming one of the most curious timing sequences of the cycle. Layered onto that is a planetary geometry, first the November 19th to 20th alignment involving the Sun, Mercury, the Moon, Earth, and Uranus, and then the even more dramatic January 9 configuration where 6 major bodies align almost in a straight line. He revisits the seismic window of the coast of Japan, acknowledging the intensity of the ongoing swarm and the parallels to previous foreshot patterns. The goal is not to alarm but to highlight the importance of paying attention when multiple natural systems become active at once. Solar behavior, cometary positions, planetary geometry, and tectonic tension are all components of a broader energetic landscape that shifts over time. Recognizing these shifts allows us to observe patterns without jumping to conclusions. His tone softens as he speaks directly to his viewers. The goal is awareness, not fear. These cosmic and geophysical patterns unfold whether or not we watch them, but understanding them helps us stay grounded. The Sun moves through cycles, planets align and drift apart, comets sweep in and fade away, and Earth responds in its own quiet rhythms. None of this requires anxiety, only curiosity and respect for the forces that shape our environment. He closes with reassurance, promising to continue monitoring these developments and translating them into clear, level-headed updates. With that calm presence is known for, he signs off, "I'm Dr. Kale Ryan. Stay grounded, stay aware, and I'll keep you updated as the cosmos unfolds."